Hi everyone, welcome back to My Age of Sustainable Development. I'm Skyler, and today we're talking about Chapter 6, Planetary Boundaries. In this video, we'll discuss the relationship between resources and development through the lens of planetary boundaries, the inherent limits of Earth. The following questions will guide this discussion. What would the future look like with current growth rates and development practices? What did Thomas Malthus predict about population growth, and how does this relate to sustainable development? What are the 9 planetary boundaries? What are the environmental impacts of agriculture, industry, and energy? And how do we grow towards a prosperous world within Earth's limits? Since the Industrial Revolution, population and subsequently industry, agriculture, and energy use have expanded rapidly. We can see in this graph from the United Nations the population growth after the Industrial Revolution and the predicted population growth into the future, with an expected 11 billion people on Earth by 2100. How can the Earth, a finite system, support continuous population growth? This question was raised by Thomas Robert Malthus, an economist in the late 18th century. In his book, An Essay on the Principle of Population, Malthus predicted that as populations continued to grow, there would no longer be enough food or capital to support them, and global populations would fall into poverty. While he couldn't have predicted the scientific advancements of the green agricultural revolution in the 1970s or new technology, he made a great point that Earth cannot support infinite population growth because of its finite resources. How can we quantify the impact of population growth on Earth's limited resources? In 2009, a group of scientists defined the 9 planetary boundaries. Each planetary boundary relates to an Earth system in which too much or too little of a resource or pollutant throws the system off balance. Planetary boundaries are quantifiable through measurements of pollutants or damages, and each has a series of benchmarks to show the severity of its crossing. The 9 planetary boundaries are: human-induced climate change. The burning of fossil fuels releases greenhouse gases, such as carbon dioxide and methane, that once in the atmosphere trap radiation and heat from leaving Earth. This trapped heat has already raised global temperatures by approximately 1 degree Celsius, with higher elevation regions seeing more extreme temperature increases. Climate change is felt globally, with rising sea levels, species extinctions, droughts, and flooding. Ocean acidification. When excess carbon dioxide in the atmosphere reacts with ocean water, carbonic acid forms and dissociates into positive hydrogen ions, which raise the acidity of the ocean. Ocean acidification changes the marine ecosystem and harms marine life who can't live in more acidic water. The acidity of the ocean has already increased by 26%, about 0.1 pH on a logarithmic scale. Ozone depletion. Harmful chemicals released into the atmosphere can weaken and eliminate the protective ozone layer. Chlorofluorocarbons, a chemical used in refrigeration, have caused a hole in the ozone layer above the South Pole. Ozone depletion increases the risk of harmful UV radiation and skin cancers. Global freshwater use. Global agriculture requires an immense amount of fresh water to operate. We are using our freshwater reserves, especially groundwater, at rates much faster than the natural regeneration. Change in land use describes how natural environments are converted into agricultural fields, herding plains, industrial sites, or cities, and this contributes to excess carbon dioxide in the atmosphere by removing natural carbon sinks. Change in land use also destroys habitats and harms biodiversity. Nitrogen and phosphorus enter ecosystems from the runoff of nutrient-dense fertilizers in agriculture. These chemicals disrupt the nutrient balance of ecosystems and lead to harmful effects, one such being eutrophication, which occurs in estuaries when nutrient-rich water allows for algal blooms that deplete the water of oxygen and kill aquatic life. Biodiversity loss. Many human actions, such as single-crop agriculture, freshwater depletion, and land use change, harm biodiversity, causing a loss in population, genetic diversity, and resilience. Many species face complete extinction, and humans are causing the 6th mass extinction in global history. Aerosol loading. Very fine particles, less than 2.5 micrometers, enter the atmosphere from burning coal, biomass, and fuel. These fine particles cause air pollution and respiratory damage. Chemical pollution is a broad term to describe all human actions releasing chemicals into the environment from industry to agriculture. This graphic shows the status of the 9 planetary boundaries today. Notice that in some areas, specifically biodiversity and nitrogen and phosphorus pollution, damages are already critical. By quantifying the human impacts against planetary boundaries, we can assess what practices must change to create sustainable development. Although we're already pushing against many of these boundaries, large population growth will continue in the future because of fertility rates and pent-up growth. Pent-up growth is the process of poorer countries catching up to richer countries in terms of average income, living standards, and technological advancement. Pent-up growth is important for creating an equitable future and will result in a quadrupling of gross world product and a population of nearly 11 billion. As populations grow, both from pent-up growth and the continued, although slower, growth of high-income countries, the sectors of energy, agriculture, and industry will also grow. Sachs says, in order to reconcile the growth that we would like to see with the ecological realities of planet Earth, we are going to need the world economy to develop in a fundamentally different way in the future. Let's look at each of these sectors and discuss how development can become sustainable. Thankfully, science and technology have given answers for how we can operate within planetary boundaries. Energy based on fossil fuels that causes climate change, ocean acidification, and aerosol loading can be changed to solar, wind, hydroelectric, and even nuclear power. These new energy systems will decarbonize the energy field, and carbon capture technologies can help eliminate excess carbon dioxide from the atmosphere. Efficient, low-till, low-fertilizer agriculture will create more food production for the expanding population while decreasing pollution, biodiversity loss, and resource depletion. A cultural shift towards local, less meat-heavy diets will also shift global perceptions towards healthier and more sustainable food practices. Economic incentives against pollution will decrease environmental damages due to industry. These changes can be enforced at the government level through taxation, permit systems, and liability laws. Community engagement is also important for shifting community practices and values towards sustainable actions. Sachs reminds us that a sustainable future is within reach. The current generation must think ahead, morally and practically, to ensure the well-being of future generations. Thank you for joining me in this discussion of planetary boundaries. Here's an overview of the key terms and concepts we've covered. If you have questions or would like additional information, please reach out to the Center for Sustainable Development.